Well, hello and welcome to all of our attendees today, and thank you for joining our webinar. Before we get started, I want to let you know that we are recording the webinar and we'll make the video available within the next couple of days. We will send you all an email with a link to the video so that you can either watch sections of the video or share it with your colleagues. Today's webinar is co-sponsored by Imaging and Analysis and also by Datacolor. Imaging and Analysis is an image consulting firm specializing in image optimization and the imaging workflow. Datacolor has been a world leader in color management for nearly 50 years, and through their ChromaCal line of products has brought their color science expertise to microscopy imaging. My name is Mark Clymer. I'm the Marketing Director for Datacolor ChromaCal, and I'm joined today by my colleague, Mark McNulty.
Good afternoon.
We're excited to have a great speaker for you today, and I'll introduce him in just a moment. At any time during the webinar, please feel free to submit any questions that you may have using the GoToWebinar control panel, and right where the blue arrow is pointing. We'll take those questions and provide answers towards the end of the webinar in our Q&A session. And now, here's our speaker, Jerry Sedgwick.
Thank you, Mark. Thank you, everyone, for being here. I'm pleased to be a co-sponsor with Datacolor. I provide consulting and writing services, most often with those who are at their wits' end to solve problems others haven't been able to solve. I've developed color calibration workflows for novel materials, beta-tested imaging instrumentation and software, developed instrumentation to optimize lighting, optics, design, and software, worked with universities and attorneys in difficult-to-determine image fraud cases, authored manuscripts for juried publications, white papers, collateral materials, and regulatory documents for the medical device industry, and was instrumental in providing quantitation services for subsequent FDA approvals of medical devices. You can find out more at imagingandanalysis.com, and you can also find instructional material there and at my linked YouTube site. In this webinar, I'll talk about why there's a need to post-process, some issues with Photoshop and ImageJ, and potential mistakes that could be made when using these programs. Then I'll move on to a solution through the use of ChromaCal, either as standalone software for image processing or with a calibration device to standardize color. Mark Clymer will then show real-world examples. So, why would you post-process? As it turns out, brightfield images from histo samples rarely look consistent after image acquisition. In this set of images, an expert microscopist, me, took pictures over more than one session, being very careful to white balance and set brightness to the same level from picture to picture. As you can see, even with careful control of camera settings, you can see differences in background color and overall color from session 1 to session 2 for the right Giemsa stain and for the IHC stains, and a difference in brightness level with the H&E stain. And these are at the same magnification. Images are even more inconsistent when using more than one objective and one magnification. So regardless of the operator's experience, the following often need correction. One thing is you need to remove the color cast, match brightness, increase contrast, and so on as you read the list. And I'll show you some images that show each one of these corrections that need to be made. First of all, you can see that with imaging that sometimes you can get a color cast in the background, and this is normally corrected through white balancing, but if white balancing isn't done, or if the camera doesn't adequately white balance, and that can happen frequently, you would need to correct this. If an image is too dark, you'd certainly want to brighten it. If an image lacks contrast, you would certainly want to adjust the contrast and brighten a muted color. And then finally, you would want to correct colors if you feel that they are inappropriate. But again, that's something that's subjective, but we'll talk more about that. You would also want to correct for uneven illumination when you have, as you can see here, a brighter background at one part of the image and a darker background at other parts of the image. And let me be quick to say that no matter how many times you've been told that if you did curler illumination, you wouldn't have that problem, you will, especially with low magnification lenses. It really comes with the territory of using a microscope. You can minimize it, but sometimes you can't completely eliminate it. And then at the end, when you're putting images in figures or when you want to use them for quantitation, you certainly want to match images one to the other to make them consistent. And I'm going to really hammer on this consistency because consistency is really important when doing scientific work, and especially when doing quantitation. So even though I pointed out all the things that you need to do in post-processing, there's always room for mistakes when you process. And so we need to be really careful about making sure that we don't make those mistakes. One of those is that the background can be made too bright. When you print this in publication, there's really no visual difference at the edge of the image that separates it from the page. Furthermore, with an image like this, you may be removing details. And here's an example of that. You can also make things too bright when correcting for brightness, and you can get a loss of details in parts of your image. You can also lose detail by overdoing the contrast setting so that you can't make out details in the darker parts of your image. And this is a mistake that's easily made. And finally, you can have issues with color adjustment. In the end, you're relying on your memory of what the color is to then determine what that color should be, or you're relying on the memory of your supervisor who has decided what that color should be. And so there really is no objective standard. And then there's the issue of when you correct for uneven illumination, generally you iteratively set a setting to determine the degree at which you divide the flat field image into your specimen image. That can remove some detail, especially in the brighter parts of the image. And by the way, a flat field image is an image that's taken of the light source without the specimen in the way. When you have that image, you then have the shading that occurs from the various areas of the picture. You can divide that in sample picture, and then you can correct for the uneven illumination. And this is critical, especially if you're doing densitometry measurements, not just for a high quality image, but also for actual measurements. When you're doing densitometry, and it sure helps when you're doing morphometric measurements as well. So, what are some of the issues then with Photoshop and ImageJ? First of all, when it comes to white balancing and setting the brightness, I've always used a method that I call the Eyedropper Method. And one thing that has always frustrated me about the Eyedropper Method is I could never really control the brightness so that from one image to the next I could have them at a consistent brightness level. And so I've been not just a little, I've been frustrated with the variable results. I've been frustrated with other things as well, but I know that for users who are not as adept at using that program as I am, it's certainly a complex program, and it's a little difficult to figure out how to do things like batch processing when you're actually using the program. So really, it's a complex program. It's definitely time-consuming. Especially when deciding how you want color or how you want contrast. It can be subjective if you're not using proper techniques. And really, in the end, the thing that's really annoying for me is the variable results. Here's just an example of something that is a somewhat complex method for correcting both for white balance and for brightness levels. And in this instance, I recommend using this method, but you have to use the levels box. You have to make sure that you set the target values, and then you have to be sure that when you actually use the eyedropper tool on your image that you don't oversaturate your whites, and that the whites stay at less than a pure white. ImageJ is really another issue for me. I tend not to bring color images into ImageJ because I find it rather frustrating. For one, just a white balance is a complex process. It's not really straightforward. And when you want to actually keep track of what you're doing, you need to create a macro in order to do that. But really, one of the most annoying parts for me is, at least in Photoshop, I can set up some color sampling points and actually see pixel values while I'm making changes, and there I can't. Here's an example of actually doing a white balancing technique according to a technique that I found on the web, and it requires that you split your image into 3 separate channels. This also does uneven illumination correction, and there on the right you can see that the uneven illumination correction was accomplished along with white balancing, but it was rather a complex process and time-consuming. So I'd always wondered, this isn't rocket science. There's only X number of things that you have to do in order to correct a color bright field image. And so I was really happy to hear about the solution from Data Color called ChromaCal. And I think what I'm most excited about is that the images are consistent, that it removes the variability from imaging. It takes so much less time, and it's just a slam dunk for batch processing. So the way that it's being delivered is you can buy it in 2 different packages. One is the Easy Image Prep, and that one is the software only, where it will do the white balancing, it will do a consistent brightness level, and it will do that among various microscope sessions and with a variety of magnifications. But it will also do color calibration to an objective standard, to actually a color target. And that really takes the subjectivity out of setting colors for your images. So here you can see a series of images going across the top, and you can see that there's variability in terms of white balance, so there's some color shifts in some of these images, and then in others you'll see that there's uneven illumination issues, and then in others it's dark. And after batch processing with Easy Image Prep, you can see that these are all brought to the same brightness level and can easily be included in a figure or for consequent or subsequent quantitation. If you opt to also get the hardware with the software so that you can image the color standard, you can then actually get colors that are closer to what you see from the samples, and more importantly are standardized to a color target. So now I'll hand this over to Mark, and he can tell you more about ChromaCal.
All right, thank you, Jerry. Let's see, here we go. So this is the ChromaCal interface. When you start it, I'm going to start by showing you Easy Image Prep, which, as Jerry explained, does automatic white balancing. and brightness adjustment. It also will do flat field correction if that's something that you would like to use. So this first thing I'd like to point out is this user interface is really designed to be kind of a one stop for all of your activities in Easy Image Prep. So anything you need to do, you can do from this one window. First step is I'm going to select a source of my images. Okay, so this is going to be doing an entire folder full of images. You can imagine you may have more than just a couple of images. You may have dozens or hundreds of images here. And it will work on any TIFF or JPEG image. The next step is to choose the destination folder. Importantly, the default would be to save into the same folder, and that's okay with ChromaCal. ChromaCal never overwrites the original. It always makes a copy of the original image, and it also saves details about the process within that processed image. So I'm going to show you here an example of an image before on the left-hand side and after on the right-hand side after Easy Image Prep. Right now, Easy Image Prep is only doing the white balancing and brightness. And you can see how there is a difference. The blue cast in the left, and on the right, the background is closer to being white. I have the option of choosing a flat field image that I'd like to use for correction, and I will choose that image here. And once that image loads, automatically ChromaCal will apply that image for flat field correction. Now you can see how easy or how even that image is on the right. If I move into this icon here on the right, we can actually view this on full screen. So there is the Easy Image Prep processed image, and then I can toggle with the space bar back to the original image, and you can really see the impact of just automatic white balancing, brightness adjustment, and flat field correction. You can pick and choose which images in a folder you would like to use for flat field. You can turn them all off, and if you'd like, you can just pick one or two to process. If you have a TIFF image, you can also save a TIFF image down to a JPEG when you do the processing. I'm going to leave them in original format and choose Process Images, and ChromaCal will automatically process any of those images I've selected and saves them into the destination folder. And that's it for Easy Image Prep. Simple. Now I'd like to show you color calibration within Datacolor ChromaCal. First step here is to open a calibration matrix image. The ChromaCal uses for color calibration, it uses a calibration slide. And this is a pattern that is on the slide. You see a series of color patches. Each calibration slide has a serial number, and we have measured the optical properties, the color characteristics of each of these patches during manufacturing. That makes the slide a standard. The image of the slide, as you see here, becomes the fingerprint or the profile of your imaging session, taking into account your light source, any filters, anything that may impart color to an image in the absence of a specimen. So the first step when your matrix image is opened, as it is here, is to align so that your white patch is in the bottom right corner, and you can use these tools here on the left. And then you want to put these squares into those patches, and the easiest way is to simply click and drag across here to zoom those. And you can see that those boxes, which are little sampling squares, are now in those patches. And when they are, then you're aligned, and that's all you need to do. And at this point, you're ready to calibrate your images. So you can calibrate a single specimen image at a time, but what most people really prefer is that batch processing, because this is really the time savings for everyone. Very similar interface here. You select your source images. This is the folder I have with my specimen images. And I will select the destination. And again, I'll just let it be the default, which is the same folder. ChromaCal always makes a copy of the original image. And here you can see an example of the original image and the calibrated image on the right-hand side. And you can preview each of your images such as this, and also in the full screen mode. That's the calibrated image. I toggle back then to the original image. Again, you may pick and choose images that you would like to calibrate. You may also save them from TIFF down to JPEG. When you're ready, just choose Process Images, and ChromaCal does the work for you. So it's that fast and that easy. Now I'd like to show you one other feature within ChromaCal, and we call it the ChromaCal Viewer. This tool is included within ChromaCal at no additional charge. It allows you to view any TIFF or JPEG image that you may have. It's not necessarily anything related to a specimen or to ChromaCal, but any TIFF or JPEG. So let me add images there from our calibration. Okay, so these are all the images that were in that folder. So both an uncalibrated image and a calibrated image. If you noticed, when I open the calibrated image, this is the uncalibrated. There's very little information here, but in the calibrated image, this is all the information that ChromaCal saves with the calibrated image, with the processed image, for complete transparency that this image was indeed processed, but it was processed to a standard using ChromaCal. Also, within the viewer, you can select an area to zoom in, and then if you like, you can then save that zoomed area as a cropped image, and it will just append the previous file name with crop. And I'm done. So that's data color ChromaCal, both easy image prep and full color calibration. Let me go back now to the presentation. And what I would like to do now is share some what I call real-world examples from customers that have shared their images with us. Now, these images here and the next couple of slides come from Dr. Ward Richter. Dr. Richter uses ChromaCal pretty much every day that he's doing his imaging as a toxicologic pathologist. He evaluates and assesses images for his clients in the biopharma industry. Before ChromaCal, however, Dr. Richter would typically use ImageJ for both flatfield correction, any white balancing or brightness adjustments that he needed to make. And I think as Jerry alluded, that's a bit clunky, a bit difficult, challenging, time-consuming. But even after doing that, he still had no guarantee that the colors were right. Now, Dr. Richter is using ChromaCal with all of his imaging studies, and he even submits the images in his reports back to his clients, his pharmaceutical customers, but also to the FDA. And Dr. Richter is particularly impressed with the ability of ChromaCal to improve the detail and definition in his images, and without any sharpening at all. Now I'll share a couple of images that were acquired with specimens that were provided by Dr. Norman Lowe of CytoVetstat. Dr. Lowe reviews cytology specimen images that he generates himself, but also receives from other veterinarians. And again, after processing with ChromaCal, our customers are saying that they see greater definition and detail within the images themselves.
Say, Mark, that this particular image makes me think of a study that was done where they found that pathologists could read slides digitally much faster when colors were more accurate. In this instance, using a monitor, it was a paper by Kropinski. They actually had a 30% increase, almost 30% increase in reading speed. So this is really nice to see something with that much detail.
And I have one final example to show you, and this example comes from a recent article that was authored by Dr. Michael Linden at the University of Minnesota, and it was published in the Journal of Histochemistry and Cytochemistry. This image shows variability that can be seen between different imaging systems or imaging sessions, as exemplified across the top row. And in the bottom row, the consistency and comparability that you can achieve using ChromaCal color correction.
Yeah, and in that paper, it actually using measuring morphometry was much easier. There was only one threshold that had to be set, and it could be set the same for all images. And also densitometry was done, and it actually was far easier to do as well.
Thanks, Jerry. Now I'm going to turn the presentation over to Mark McNulty to explain a special offer that we're going to give to all of our webinar attendees. Mark?
Well, thanks. Hopefully you saw from Jerry's discussion as well as Mark's the value that can be derived from ChromaCal, but we always think that the best evidence of its value is to get it into your hands and have you use it in your own lab with your own equipment, your own images. So we will be providing each attendee at today's webinar with a software download link, and we'll give that to you in both Windows and OS X, depending on your environment, and we'll send that out. And please, you can use it immediately for any of your images, and we encourage you to do so. And if there are any questions as you use it, please feel free to contact us. Now, for those who may be interested in taking their imaging even further with color calibration, then certainly we also offer trials with the calibration slide. So give us a call. Let's talk. Let's understand your environment, and if that option makes sense, then we'd be happy to facilitate a trial there with a calibration slide. You can, if you're interested in that option, if you go onto our website, there's a free trial special offer link, and if you provide your information, we'll be sure to get back to you in short order. And then lastly, I know some of the audience is representing or are representing camera OEM system integrators, etc. And the question, although most of our discussion was really centered on those using the microscope, for OEMs and integrators, certainly the same technology underscoring ChromaCal can be used in a number of different applications to integrate, whether it be factory calibration, field calibration, or even building the ChromaCal tools into the image capture software used at the microscope. So we are open for discussions, and again, you can contact Mark or I directly or through the website to discuss that in further detail.
Okay, Mark. Well, now it's time for our question and answer session. You still have an opportunity to submit any questions you may have through the control panel in your GoToWebinar control panel, so in the question section. I'd also like to mention that we do have a lot more information about microscopy and imaging and color on the ChromaCal website, so please feel free to visit us there as well. So let's now go on to some questions. All right. Jerry, here's a question for you. Is there any good time to use Photoshop for scientific images?
Yeah, for layout, it's really a good tool to use, and for preparation for publication. There's an auto layout plugin or add-on at the website, and you're welcome to go and check that out.
All right. Here's a question. Can you also use ChromaCal for digital pathology images? ChromaCal doesn't know what purpose the images are for. The digital pathology, ChromaCal will use JPEG and TIFF images. So if this is if you're asking about whole slide images, save a region as a TIFF or a JPEG, and yes, that can be used with ChromaCal. Also wanted to just add to that we do have customers who use our calibration slide for quality assurance, performance measurement, and monitoring of their whole slide scanners over time. So it's a way for them to see how they change, maybe light source and so forth, but over time, and they can then advise the engineers to come in and do an adjustment if needed.
Yeah, we didn't show you that capability of the ChromaCal software today, but if anyone's interested in that, certainly feel free to contact us, and we can take you through that capability specifically.
Okay. Okay, here's an easy one. Mark, I'll let you take this one. How much does Easy Image Prep cost, and are there any other fees?
That's a great question. Thank you. We've designed Easy Image Prep to be a very value-add process. So we've priced it to be a flat one-time fee of $349. There are no monthly fees. There are no annual fees. You get upgrades as well as any maintenance releases as they occur. Anytime you open up the software, it checks for the latest release and allows you to download it.
Okay. Here's a customer. This is supposed to be for Jerry. Customer says, already have Photoshop. Do I really want to buy another software program?
If you're interested in saving time, I certainly know of people who have complained to me that their supervisors think that imaging takes a very short period of time, and 3 hours later they're still working on it. I think that for $349, it's certainly worth saving immense amounts of time.
Okay. We've got time for a couple other questions. We will, if we don't get to your question, we will respond to you separately. Let's see. Can ChromaCal be used for fluorescence images, and what about macroscopic images? I'll take that. ChromaCal is designed for transmitted brightfield color images. So those color patches, as you can see, are really for brightfield type imaging, and the slide itself is not can't be used in fluorescence. But as far as macroscopic images, yes, we not with our slide, but we do offer macro targets, which are printed targets. They can be used in various forms of macroscopic imaging, like gross pathology, gross anatomy type.
And it's the exact same software, so all you would do is buy a different target and image that target macroscopically, but the software process would be exactly identical.
Time for one more question, and this is a good one that addresses some of the detail in the images that appears to be improved after processing. And the question is, can we confirm that there's no loss of resolution after manipulating the image? We don't change the pixels at all. We are changing really with color calibration, the sensitivity, if you will, of the color gamut for that image. So the resolution doesn't change at all. It's just an appearance that there may be sharpening in an image, but in reality we don't touch that at all. So that's all the time we have today. We want to be sensitive to your time, and we do appreciate your attendance during today's webinar. And I do want to finally remind you that we will again be sending you links for the Easy Image Prep software download, and we do encourage you to try it. We'll also be providing you a link to the recording of the webinar when that is available, so you can share that and watch it for yourself. And with that, I'd like to thank everyone for attending today's webinar, and thank you very much for your time. Thank you, Jerry. And everyone, have a great day.